Alright class, so today we're going to model a Lewis dot using silicone 2, fluorine 2, and hydrogen 2. Now we have to learn how much each has. Valence electrons, silicone has 4, fluorine has 7, 1, 2, 3, 4, 5, 6, 7, and hydrogen has 1. Just because. And well, when we go down to model it, it's going to look something like this. Fluorine is going to pair up with itself with 4 in the middle, and it's going to have 2 on the top and 2 on the bottom, of each one, and 1 on the side. And this is going to be satisfied with a hydrogen one, which shares 1 and replicated on the same side. And hydrogen is going to pair up with silicone and share 2 in the middle as a pair, and going to have 2 extra on the outside. And the same thing, where it's going to be silicone on the outside. And now we're going to come down to it and model it with all the lines and such. And as you can see, we're going to have to put a fluorine in the middle with 2 lines signifying 2 pairs, a line on top, 2 lines on top, and 2 lines on the bottom to signify the pair as you've shown us in class, a line to signify the pair between fluorine and hydrogen, and a line to signify the pair between silicone and hydrogen, and a line on the outside to show the pair, which isn't unshared actually. And we must replicate the results on this side using hydrogen and silicone, and that's how you model that. And now we're recording MnO4 with a negative charge, and it's going to be new, but always we have to label how many valence electrons. Mn has 2, and oxygen has 6. And so when we model it, this time we're going to try to put Mn at the center with the 2 on the sides, and satisfy it with oxygen at first, to satisfy the 2 with 1 each. Then, so we get 1, 2, 3, 4, and then 5 to complete the 6. But now it's uneven, but we'll get to that later. And obviously replicate the result on this side, so you have a 6. And then you put the 2 at the top and the bottom, so you just have the pair to attach it also. So then you get the 6 right there on its own. 1, 2, 3, 4 to get the 6 on that, and 1, 2, 3, 4 to get the 6 on that. And well, what happened when we have a negative charge, so now you have to satisfy an electron with a negative on that side, and a negative on that side. And so it's different now. And now obviously you have to label what it's going to look like, so we have to have Mn with the line pairs attached to oxygen on each side, obviously. And instead of, lining it, we have to draw out each one. And the oxygen, we draw out the negative, so just so we know. Same thing for this one, and same thing for the very last one. We have to draw the negative electron. And overall, as a change, we have to bracket the entire thing out to show it's been shelled on each side. And at the very end, negatively charge it to show it's a negative. And that's MnO4 negative.